Hello everyone. In this brief ESP32 microcontroller tutorial, we briefly explain how to establish a Wi-Fi communication interface between a computer and an ESP32 microcontroller. In particular, we explain how to remotely turn on or off an LED attached to the ESP32 microcontroller. For example, if I click over here, the LED will be turned on, and if I click over here, the LED will be turned off. Here, I'm running the simple script in my web browser. This web browser running on my computer acts as a client. Once I click over here, that is, once I want to turn the LED on, a message is being generated. This message is sent through my Wi-Fi network to a server. The server is implemented on my ESP32 microcontroller. The server receives the message, and depending on the type of the message, it will turn on or off the LED. The experimental setup is very simple. I'm using the ESP32 microcontroller. In particular, I'm using ESP32S3 Dev Kit C. Then, it consists of an LED and 330 ohm resistor. This port is attached to the pin 5 of ESP32, and this port is attached to the ground of ESP32. This script is running on the ESP32 microcontroller, and it completely governs the communication. This script connects to the Wi-Fi network and establishes the communication between the client and the server. The main ideas presented in this tutorial are very important for practical robotics and Internet of Things systems. Namely, you can easily generalize the ideas presented in this tutorial to remotely and over the internet send control actions to robotics and mechatronics systems and to receive back sensor readings and sensor information. Then you can integrate everything in a web browser, and you can remotely, for example from your phone, control optomechatronics or mechatronic systems in your house. Okay, let's start with the explanation. To be able to properly understand the script that implements the Wi-Fi server, we first need to properly understand several important communication concepts. The figure below shows a simplified block diagram of the communication graph. On one side of the communication network, we have a client, and as we mentioned previously, a client is nothing less than a web browser running on our computer. On the other side of the communication graph, we have a server host. The server is implemented and is running on our ESP32 microcontroller. Our client sends messages or requests to the server, and the server sends back messages or replies or responses to our client. In this tutorial, as well as in other books on communication, you will often see this abbreviation, HTTP. HTTP is an abbreviation for Hypertext Transfer Protocol. It is a protocol used to define and govern requests and responses over the internet or over local Wi-Fi communication networks. For example, similarly to what we did at the beginning of this tutorial, a user enters the address of the host in the browser address bar. Then, after the connection is established, the client sends the so-called HTTP GET request to the server to obtain information and data about the HTML document or a web page that should be displayed on the client's computer screen. The server replies by sending the requested HTML document or data, and the client, in our case our web browser, displays the data, messages, or a complete web page on the computer screen. The GET request looks like this. It has two lines, and in addition to these two lines, it might have other lines that are specific to the web browser or to the client. However, these are the two most important lines. This first slash over here denotes the start of the path on the host. After this symbol, the client might specify the path. Namely, after this slash, the client or the user might specify paths or names of web pages, objects or images, or something else on the server. Then, HTTP/1.1 is the type of the protocol. This is a standard protocol name. The second line is the address of the server host. In addition to these two lines, there might be several additional lines depending on the client's browser. If the server is able to recognize and locate the requested path, then it replies with a message whose header looks like this. We have again two lines in the header. The first line means that the server is able to recognize and understand the protocol that the client intends to use for the communication. That is, the server understands the HTTP/1.1 protocol. 200 OK is the HTTP status code indicating that the address, path, or the object, or generally speaking, a resource, has been located on the server. The second line indicates the type of the data that will be sent back to the client. On the other hand, if the server is not able to locate the path or the resource that is requested by the client, then the server should send the following reply. And I'm 100% sure that you have seen many times this message, 404 not found. Here, HTTP/1.1 means that the server recognizes and understands the protocol, and the famous 404 not found means that the resource cannot be found. Usually in practice, either the resource does not exist on the server, or the user did not properly specify the address of the resource or the path on the server. Now that we understand the basics of communication and what is the purpose of the client and what is the purpose of the server, let us explain the script implementing the Wi-Fi server. The first step is to attach your board to the computer and, of course, to build a simple LED resistor circuit. Under the assumption that you did that, and to briefly summarize, the LED should be connected to the pin number 5, and the other side should be grounded. The purpose of the resistor is to limit the current through the LED. Otherwise, the LED will explode. Okay, the next step is to properly identify the port. So click on Tools and make sure that the proper port is selected. Then click on Tools, then click on Board, and over here select your board. In my case, it is ESP32S3 Dev module. Okay. If you don't know how to install ESP32 and how to use ESP32 in Arduino, we created a separate tutorial explaining how to install ESP32 boards in Arduino IDE. A link to that tutorial is given in the description below. Okay. ESP32 library for Arduino comes with a number of examples explaining how to implement different communication interfaces. And we will be using one of these examples, and we will slightly modify that example. So how to locate the examples? Click on File, then click on Examples, and over here you need to locate the proper examples. You can see a bunch of examples, and you need to find Wi-Fi. And over here you need to find simple Wi-Fi server. So open it. Again, you need to click on File, Examples, then scroll down under this section containing ESP32, find Wi-Fi, then you'll find simple Wi-Fi server. Okay, so here is a simple Wi-Fi server. Let's expand this window and let's explain everything line by line. First of all, you need to include the header file of the Wi-Fi library. Over here, you need to define two very important things. First of all, you need to define the name of your wireless network. How to find the name? Well, you can click over here And you can see that I'm currently connected to the setup 81DE. Consequently, over here, I need to type setup 81DE and make sure that this string completely matches this string. This is very important. Over here, you need to enter the password that you use to connect your computer to the wireless network. I'm not going to publicly disclose my password, and consequently I will just type a random password. Later on, I will adjust this password such that I can actually establish the communication. Over here, we define the server, and here is our setup function. For those of you who are not familiar with Arduino or with ESP32 microcontroller boards, the setup function is only executed once. It is executed after you upload the script, and it's executed after you press the reset button on your board. Over here, we begin the serial and we specify the baud rate. Then we set the LED pin mode. The LED will be connected to the pin number 5 and the mode will be output. Then we introduce small delay. Over here, we print the message connecting to and the name of the network. And over here, we are trying to connect to the Wi-Fi network. This while loop will run until we connect to the network. After we do that, we print a very important information. Over here, we print the local IP address of our server. And this information will be copy and paste in our web browser. And by using this information, we will actually connect to the server. This will be explained later on. And over here, we actually start our server. Simple as that. Not too complex. To be able to properly explain the rest of this code, I will upload the complete sketch. And note over here that I changed the password such that the password completely matches the password I'm using to connect to Wi-Fi. Okay, so let's upload this code and let's see what will happen. It will take some time since we first need to compile and after that we need to upload. Again, if you don't know how to upload ESP32 scripts to the board, watch the previous tutorial I made. Okay, you're almost there and you can see over here. Okay, you need to wait until everything is explained. Okay, so let's see. Click on Tools and click on Serial Monitor. And you can see this. Congratulations! Connecting to setup 81DE, setup 81DE, and here is the IP address. This is the local IP address. Okay, so let's go back to the function and you can see over here that the IP address is being printed out. And this line is actually this line over here. Okay, let's continue. To start the client, we need to copy this address. This is very important. And we need to open a web browser. And we need to paste this address. So what will happen over here? Once I press the enter, an HTTP GET request will be generated. And it will be sent to the server. So let's do that. Press enter. Okay, you can see that something popped up over here. This is actually the information and the web page or the HTML code that's being sent back from the server. Again, once I pressed enter over here, the server, or actually the client, okay, again, the client generated an HTTP GET request. Then, as a response, the server sent this HTML code that's being displayed on the computer screen. Okay, now let's go back to Arduino and let's analyze what's written in the serial monitor. Initially, we had only these 3 lines, and we can see over here, new client. Okay, now let's go to the void loop function. And let's analyze this part over here before we explain this line. So what's happening over here? This void loop was just running until server.available returned something. And server.available returned something at the moment I pressed enter over here. That is after I entered the address and pressed the enter. Then the rest of the code started to execute. Since client is no more 0, there is 1 or true, this piece of code is executed. Let's analyze this code. First of all, over here we print serial print line new client, and that's precisely this line. And then from here, that is this part starting from here until the end, is actually the get message that's being generated by our client. So we can see the standard first 2 lines that we explained at the beginning of this tutorial, get /http/1.1 and the host address. And these additional lines are the lines generated by my browser, and they're not important, so you can simply ignore them. Now something else happened, client disconnected, and then we have again our client, and we requested this icon. This is just a standard thing, don't worry about it. So some kind of icon is being requested, and we can see it's being requested from the host. And again, this part is the same, and the client is disconnected. This part and this part is printed on our serial monitor. That is, it's printed on the serial monitor that is being run from our ESP32 board. This is not directly the message that's sent from the client. That is, the client doesn't print to the serial monitor, it sends the messages to ESP32, and then ESP32 prints things on the serial monitor. These lines are printed on the serial monitor like this. First of all, while the client is connected, this while loop is executed. Okay, if client.available is true, then what do? We read the information sent from the client character by character, and we write them on the serial communication port character by character. This is very important. Now, if we encounter a new line character, this part will be executed. This part will be executed actually once the complete message starting from here to here is being read and written on the serial, and after that, after we encounter a new line. This is very important. If the new line is encountered, then if this condition is satisfied, and I will explain what a current line actually is, then what do? We send back the response. That is, the server sends back the response, and this is the header of the response. This means that, okay, we understand that this is HTTP 1.1 protocol, and we received everything, so we send 200 OK, and then we describe what type of a content we are sending back. We are sending a text and HTML. Then we print a new line, and over here is the most important part. This is an HTML code that's actually displayed over here in our client's web browser, and this is very important. The server sends back the HTML code, and the client actually displays the HTML code on the computer screen, and you can see the HTML code over here. this is actually here, this is a link, so if we press here, H will be generated, and if you press over here, L will be generated, and you can see it over here. We will generate H as a message, and we will generate L as a message. Okay. Then the HTTP response should end with another blank line, that is the response from the server after specifying the HTML code should have a new line, and we break the while loop. If actually this is not satisfied, then the current line will be empty, and I will explain current line later on. Else, let's see else. Else is actually from this if. So if there is no new line, what do we do over here? And if there is no the carriage return character, we just add everything that is a character to the end of the current line. And this is very important. Let's explain the current line. After this initial execution, we will actually store the response from our client in the current line. Again, C is the character being read from the client, and we will store everything in the current line. And by monitoring the current line, we will be able to decode the message that's being sent. If we press over here, a message will be generated. And let's see that message. You can see it over here. Actually, the message get/h will be generated. And if the current line ends with that message, then we will digital write to our pin high. On the other hand, if the current line ends with L, that is, if we press over here, L, a message will be generated, and the form of that message again is get/L, and what will happen? We will turn off the LED. Simple as that. Okay, now you can see the messages over here. I press L, and you can see the message over here. So this message is being generated, but not only this message, everything starting from here until here. Again, I will have an additional part requesting from an icon. However, I don't need this part. So the most important thing is this part over here. Now let's go back again, and let's turn on the LED, and let's see the serial monitor again. So where is the message? Here's the message from here until here. The most important part are these two lines, get H. Okay, this means that the new line ends with, that actually current line ends with get H, and we need to turn on the LED. Simple as that. After that, we close the connection and we simply print client disconnected. And that's it. This code is actually not complex, however, you will need some time to properly understand it.